recurring decimals and fractions. So this video is going to be about converting between the two. But first of all, what is a reoccurring decimal? We know what a fraction is, but what is a reoccurring decimal? So, if we think of this fraction, a third, what that actually is 0.33333 forever as a decimal. So there we say it's recurring because the 3 is recurring, but the way we do that, a simple way, right, is we put a dot on top, just to show that, like, I don't know about you, but I don't want to spend my life, like, continually writing 3. It's not worth it. Okay, let's look at another example. So maybe this, 0.56 dot. Now the dot is only on the 6, so that means that you do 0.5 and then the 6 recurs, so 6, 6, 6, 6. So that means just the 6 recurs. If we have something like this, 0.123, and there's a dot there and a dot there, you repeat from where the dot starts to where the dot ends. So it's not just the 1 repeating then the 3, you go 0 point and then this whole bit from the start to the finish of the dots repeats. So 1, 2, 3 repeats. 1, 2, 3, 1, 2, 3, forever. Okay, so that is what a recurring decimal is, but how do we know when we have a recurring decimal? So the answer is this, it's when the denominator, so what is the denominator? That's the bottom of the fraction. So the denominator of the fraction, the bottom of the fraction, has prime factors that aren't only 2 and 5. So prime factors are factors, numbers that go into it, but they are prime. So let's have a look at some examples. So let's say I wrote down a third, which I've told you it's a recurring decimal. But if I wasn't sure, how do I know that? Does it fit this criteria? So it says the denominator of the fraction, so this 3, has prime factors that aren't only 2 and 5. And the prime factors of 3 is a prime number, so that is 3, and that's not 2 or 5. So that one is okay. What if we look at like 3 over 35? Is that a recurring decimal? Let's have a look. So it's the denominator of the fraction. Does it have prime factors that aren't only 2 and 5? So what are the prime factors of 35? It's 5 multiplied by 7. So they're both prime. Okay, so they're the prime factors, 5 and 7, that aren't only 2 and 5. So, yes, it has a prime factor that isn't 2 and 5, because this 7 is not 2 and it's not 5. So that we know is a recurring decimal. Now we write down another example. 13 over 24. Is this a recurring decimal? So let's have a look at the denominator and what are the prime factors. So 24 is 6 multiplied by 4. 4 is 2 multiplied by 2. We're kind of just doing like a little impromptu factor tree here. Circle those because they're both prime, and 6 is 3 multiplied by 2. Circle those because they're both prime. So does it have a prime factor that isn't 2 or 5? Yes, it does, because 3 is in there. So therefore, it's a recurring decimal. Okay, so there are 3 types of examples we can do, and 3 types of ways you can get asked a question. Type 1 is, for example, if we take this recurring decimal and we want to turn it into a fraction. So it's a recurring decimal into a fraction is type 1, but it's specifically when the recurring part starts immediately after the decimal place. So example type 2 is when the recurring doesn't start immediately after the decimal point. So type 1, we're going from recurring decimal into a fraction, and the recurring part starts just after the decimal point. So let's run through the steps. This is just, again, once you see it once, you just kind of learn what to do like a recipe book. So what we do is we call R what we have in our question, our recurring decimal. And we know that R is 0.123, 123, 123, etc. What we do then is we want to get one set of these over the other side of the decimal point. So what we do here is, because there's 3 parts here, we multiply by r by 1,000, so we can go 1, 2, 3 with the decimal point and get 1, 2, 3. Oh, wrong place. Basically, our aim is to get another one where we have the same exact point recurring straight after the decimal point. So as you can see, this starts from 1, 2, 3 recurring, and so does this one. So we multiply by 1,000 and we get the same part after the decimal point. The next step is to, you'll see why we did that, is to subtract r from your 1,000 bit. So if we do that, we have 1,000 r take away an r. That gives us 999 r. Then the reason we've done this and multiplied by 1,000 is because we're going to do, I haven't actually written this out, so what is r? 0.123 recurring. So 1,000 r minus r is 999 r. This part we have 123.1231313 take away 0.123131313. So basically, the reason we've done that is now these parts after the decimal point subtract, so they cancel each other out. So we're left with 123. So that is why we get this part, so we have the same part after the decimal point, so we can then get rid of it. Okay, now we rearrange to find r. So it's 999 on this side, multiplied, so when we take it over the other side we divide, we do the inverse. And then we have our answer, because this is r. R was this, and this is r, so you know that that fraction there is 0.123 all recurring. So we'll see another example of how you do that in a minute. So again, it's just practice makes perfect, and you have this bit, this bit might change, so the multiplying by 1,000, if it was just r equal 0.12, 2 points after, you'd only need to multiply by 1, 2. You'd only have to multiply by 100 and get that, and then do 100r, subtract r. But the method, like the principle, is the same. So we'll go on to an example of a type 2, which is very similar. So a type 2 is if we have something like this, 0.56 dot. So that is, we're going from a recurring decimal into a fraction. So we're converting, but this time it's not straight after the decimal point. So we've got a 5 there that isn't recurring. So that's the difference between 1 and 2. Okay, so we're going to follow some similar principles here. So we start with the same first step where we call r recurring decimal 5, 6 dot. And we're going to try and do this whole thing of trying to create the same thing after the decimal place again. So what I'm going to do is I'm going to first times r by 10 to get 10r on this side, so I times it by 10, move the decimal point over 1, so I get 5.6 recurring. But as you can see, we don't actually have the same thing after the decimal point yet, so I'm also going to do it again, but this time I'm going to times by 100. So I'm going to do 1, move decimal point 2 to the right, 1, 2, so I get 56.6 recurring. So now if we look at these two, the 10r and the 100r, we can see that they have, I've kind of cut it off there, but they have the same thing after the decimal point. They have this purely just the recurring part after the decimal point. 6 recurring, 0.6 recurring. So our next step is the same thing, so this time we do 100r, because again the whole aim is to get rid of this annoying recurring section after the decimal point, and you subtract them. So 100r, but this time you're subtracting 10r instead of just r. So that's the difference between step 1 and example 1 and example 2, just because of this needing to get the recurring bit after the decimal point. So let's do that. 100r subtract 10r is 100 minus 10, which is 90r. This time we have 56.6 recurring minus 5.6 recurring. So the 0.6 recurrings go. That was the whole point. So what's 56? Take away 5 gives us 51. Now, same stage as before, rearrange for r. R equals, take the 90 over, is multiplied by r on this side. So you do 51 divided the inverse by 90 on this side. And that's r. And as we know from the question, r is what we call this. That is the reoccurring decimal we wanted to convert into the fraction. So that's an example of how you do a type 1 and a type 2. Our final thing is going the other way, fractions to recurring decimals. Let's look at that. Okay, so type 3 is working the other way. So I'm going to get a fraction 12 over 33 into a recurring decimal. So this is doing the opposite way to what we've just done. Now there are two ways to do this. So way one, that's a bit of a weird way of saying it. Anyway, the first method is just divide method. So what this is just telling you to do is basically do the fraction, what it says. So 12 over 33 is saying 12 divided by 33. So the first way to find out what the recurring decimal is just to do the long division. So we put 12 there and 33 there. Okay, so first of all, how many 33s go into 12? Well, 0, because there's not enough. So what's the remainder? And we have 12. So how many 33s go into 120? And the answer is, so you need to put the point there, 3, but we have a remainder, 21. So now, how many 33s go into 210? And the answer is 6, but we have a remainder, and that 12. So how many 33s go into 120? And that here we have the same thing, we knew it was 3, remainder 21. How many 33s went into 210? It was the same 6, remainder 12. And as you can see, we're getting a bit of a pattern here. So we're seeing that the 3 and the 6 repeat. So the recurring part is going to be 0.36, and then that whole bit is recurring. So that's the first method, just doing long division. The second way you can do this problem, which you can't always do, but it's very nice if you can do it. I call this the 999, like 999 emergency call for help. So let's take our fraction, 12 over 33, and the way it works is you want something with just 9s on the bottom. So 99, 999, 9,999. So you're trying to look for a denominator with 9, 9, 999, etc. on the bottom. So can we get 33 to be something with 9s? So can we make 33 99? Yes, we can, and that's by multiplying by 3. Because we're so fab at fractions, we know that if we've done that to the bottom, we need to do the same thing to the top. And we get 36. Okay, so we have 36 over 99. So the way that works is you do 0. Then you just put this 36 or 36 there, and recurring. And you put it there because it's 99, which is close to 100, and 100 would be the two zeros kind of stand for this point. I'm kind of explaining that badly, so let me just tell you what I mean by doing. If I had 36 over 9,999, for example, it wouldn't be the same as that. You do 0. Then because there are 4 here, you need 4 places after here, 0, 0, and then you do the 3, 6, and all of this is recurring. If I had, so just, reinforcing the point, if I had 36 over 999, I need 0. I need 3 points after this, so 0, and then do the 3, 6. So you've got to fill up the space basically, and then all of that would be recurring. So let's now move on to some exam questions. Prove that 0.47 recurring can be written as 43 over 90. So first note, we've got recurring and we're going to a fraction. So we know we're going to do this recurring decimals to fractions, and we know that it's a type 2, so I'm going to put a 2 here because it's not straight from the decimal point that it starts repeating. So the first step is we name what we want R. Now we know we're looking for two things that have the same thing after the decimal point, which is going to be the 7 recurring. So if we do R multiplied by 10, that means we're going to have 4, so we've shifted the decimal point, 0.7 recurring. So that's what we want. First step, we want to multiply it by a factor that then has the recurring bit straight after the decimal. Okay, let's now multiply r by 100, so we have something with the same thing after the decimal point. 1, 2, 47.7 recurring. Okay, nice. We've achieved our aim of having these two things have just 0.7, we'll have 0.7 recurring after the decimal place. So now let's do 100r, which is 47.7 recurring, subtract 10r, which is 4.7 recurring, see what we get. So 100r, subtract 10r, leaves me with 90r's. And we have 47.7 recurring, subtract 4.7 recurring. So these go, that's the whole point of why we're doing it. And we're left with, so 47, take away 4 is 43. Now we rearrange to find r, so we have r equals 43. The 90 was in the way here, so we take it over the other side of the equal sign and do the inverse operation to multiplication, which is division. And r was what? This, so this 43 over 90 is r, this is r, 0.47 recurring, just like they wanted in the questions. It's always nice when you know you've done it right. Okay, so we've got 5 over 6 to a decimal. Now the first thing to do is look at the denominator, 6, and look at its prime factors. 6 is 3 multiplied by 2, and these are prime. So these are the prime factors. Are they only 2 and 5s? No, they're not, because there's a 3. Therefore, we know it's going to be a recurring decimal. Okay, so we've established that, and we know there are 2 ways to do this. So we can either do our 999 way, but trying to get 6 to equal 99, that doesn't work, it doesn't divide in nicely. None of them divide in nicely, even 999. So I'm going to go with the step 1 method. So we're going to go for the step 1, just divide. So just do long divisions. So how many 6's go into 5? Well, there's 0, but we have a remainder of 5. So put the decimal point in, don't forget. So how many 6's go into 50? And that is 8. But 6 times 8 is 48, so we have remainder 2. How many 6's go into 20? And that's 3. But 6 times 3 is 18, so we have remainder 2. So how many 6's go into 20? We just did that, it was 3, but we had remainder 2. How many 6's go into 20? Oh, we just did it. Is there like an echo here? I'm feeling a bit deja vu. Okay, so basically 3 through 3, we're seeing the pattern there, so it's going to be 0.83 recurring, the little dot.